Hello students, in this video we're going to learn how to use the shoelace method to find the area of any figure that are 3 sides and above. Alright, the name shoelace I think is derived from how you actually tie the shoelace in the shoes. Okay, so if you look at this pair of shoes, I would like you to remember the pattern, okay, how the shoelace actually crisscross one another. Okay, and then how we can actually relate that to the method we're going to learn at the next slide. Alright, so this shoelace method can be used to find area of any figure that are 3 sides and above. So let's start off by finding the area of a triangle. Alright, so supposing we have a triangle that have 3 points, starting with point A, where I call it x1, y1, and then point B, where I call it x2, y2, point C, where I call it x3, y3. Alright, so the derivations, it's very long. Basically, this is how the formula comes about. You start off by having a rectangle. Okay, so you find the area of a rectangle. Okay, so you would have this point here where the x coordinate is x2, the y coordinate will be y3, and then we have this point here also where the x coordinate is x2, y coordinate is y1, and then this point here, x coordinate is x1, y coordinate is y3. Right, so basically what we need to do is to find this distance, which is just y3 minus y1, right? And then find this distance here, which is x2 minus x1. Right, so you find the area of this rectangle, and then you minus away the area of this triangle, and this triangle, okay, to get the area of ABC. Okay, so we're not going to show the derivation here because it's very long and also involve a lot of algebra, x1, x2, x3, that kind of thing. I think you will see until you see stars. So what I'm going to do is I'm just going to teach you how to use the formula. Okay, how to use the formula, and then how we can actually use this formula to solve questions in the chapter of coordinate geometry. Okay, right. So the area of the triangle ABC, okay, right. So there will be a half there because if you were to remember what we did earlier on, it's actually the area of a rectangle minus away 3 other smaller triangle, right? So the area of a triangle is half base times height. So basically, after you have done all this tedious step, right, the ultimate formula there will be a half there, okay, and then a vertical line, and basically we just arrange all your coordinates in a vertical form, starting with x coordinate first, and then followed by the y coordinate. So we start with point A, right? So you have to remember very clearly wrong. You have to remember well, okay, remember well that the directions of the arrangement must be done in a anti-clockwise direction, okay, must be done in anti-clockwise. I think some people will say it doesn't matter lah, you know, anti-clockwise, clockwise, you still get the same answer. No, okay, it's advisable to remember to take the arrangement of your coordinates in anti-clockwise direction. So you start off by having x1, y1, followed by x2, y2, followed by x3, y3, and then you must always go back to your x1, y1. Okay, so if you, and then end up with another vertical line. Okay, right, so one thing to remember is that if you have finding the area of a triangle comprises of 3 points, then in the end you should have 4 sets of data, not 3 sets, it's 4 sets, because you start with the first point, that's x1, y1, and you also end with whatever point that you start first. So if you start with point B, let's say you can also start with point B, doesn't matter. If you start with point B, in this case here is x2, y2, right? And then you go on to x3, y3, right? go on to x1, y1. Then you must end with x2, y2. Okay, that is the important thing you must remember. All right. Okay, so how do we evaluate? How do we evaluate this vertical bar here? Right. So this is how we do it. Okay. Right. So can you see it's how you actually tie your shoelace? You go this downwards first, up down first. So basically you're just taking the values of x1 times the value of y2, then plus, okay, plus the value of x2 times y3 plus the values of x3 times y1. All right, and then you minus, okay, and then you tie the shoelace the other way around, as highlighted in the blue for you. So you bracket it. So it's x2 times y1 plus x3 times y2 plus x1 times y3, and then you close it up. So this is how the formula will look like. Okay, so it works for any figures that is 3 sides and above. All right, so take a while to try to remember, to digest, to understand. Okay, and then we're going to use that to find area of some quadrilaterals. Okay. All right, so we're going to practice now having some, rather than using x1, y1, the kind of thing, right, we're going to have some values, okay, some values, back using the same triangle ABC. But now I'm going to have some values for point A. Let's say point A has x coordinate 2, y coordinate 3. Point B has x coordinate 10, y coordinate 7. Point C has 5 as the x coordinate, 16 as the y coordinate. Okay, I'm going to find the area of this triangle. Okay, remember to take it in anti-clockwise direction. So let's start off by write down the formula first. So the formula is half. All right, and then you arrange your coordinates in the vertical form, x coordinate first followed by y. So I start with point A, but you can start with point B or point C. So since I start with point A, I need to end off with point A. So it's like basically going one round. You know, you start off, point A is like your home, like that. You go out of the home, you must come back to the home, right? So you start with point A, ends with point A. All right, so what's the next step? So the next step is, yes, you have the half there. All right, so you take 2 times 7 plus 10 times 16, that gives you 160. So 2 times 7, you just use your calculator to get 14. 10 times 16, 160. 5 times 3, 15. All right, and then you minus away the other direction, which is 3 times 10 gives you 30. 7 times 5 give you 35. 16 times 2 give you 32. Okay, one thing to take note is you must make sure you actually bracket it. Can you see I have a bracket here, and then also I need to bracket this. That means the same direction you bracket it, right? Okay, then this whole chunk of thing, all right, you can just use a calculator to help you evaluate the answer. Okay, you just key into the calculator correctly, half with a square bracket, and then with a bracket 14 plus 160 plus 15, close bracket minus open bracket again, close, and then with a closed square bracket. And so you will get the answer to be 46 units square. So this is how you apply the shoelace method. All right, let's look at slightly harder questions. So in this case here, I'm given a polygon. Okay, this polygon have how many sides? 1, 2, 3, 4, 5. 5-sided. Is it 5-sided polygon? All right, yes, it's a 5-sided polygons. We asked to find the area of this polygon, and then part 2 is to show that the area of ACDE is 25.5 units square. All right, so first thing first, we're going to just sketch the points. Okay, let's sketch the points, see where are all the points. So let's start off with point A, point B, C, D, and E. All right, next thing we join them up, join all these points up using line segment to get the polygon. So 1, 2, so we have let me use a highlighter. 1, 2, 3, 4, 5 is. This is a 5-sided polygon. All right. Okay. So what do we do? Yes, let's arrange them. Okay, arrange them. So I start with point A. All right. You take it in the anti-clockwise direction. Anti-clockwise direction. So start with point A, which is -2, -5. Not to forget, the half must be always there. Some students forget about the half there. Okay, start with the half and the vertical line. Then you arrange all your coordinates. Starting off with the x coordinate first, followed by y coordinate. So -2, -5, followed by 3, 5, 1, 8, 0, 9, -3, 1. Go back to -2, -5. Just remember, when you come out of the house, you always like to go back to the house, right? So same thing, you start with point A, you end off with point A. You start with point E, you end off with point E. Okay, right. So what do we do? So that will be equals to half. All right, how do I get 38? So we're going to simplify the calculations, okay? Sometimes if you were to do what I've done earlier on, basically by writing bracket -2 times 10 give you -10, and then plus 3 times 8, which is 24, and then plus 1 times 9, which is 9. 0 times 1 is 0, and then -3 times -5 is +50. Okay, you see that it's a rather tedious way of doing it. So instead of doing it, we would really try to make use of the calculator as much as possible, especially in exam. Time is very limited. So we should make use of calculator as much as possible. So use your calculator to just key in -2 times 5 plus 3 times 8 plus 1 times 9 plus 0 times 1 plus -3 times -5, and you will end up get 38. Yes, okay, you will get 38. All right, so then minus away the other direction. So the other direction is, again, use your calculator. Okay, -5 times 3 plus 5 times 1 plus 8 times 0 plus 9 times -3 plus 1 times -2, and you end up get -39. Okay, and again, use your calculator. Okay, use your calculator as much as possible to help you in the calculation. All right, you get 38.5 units square for the polygon ABCDE. All right, so the next step is that we need to show that the area of ACDE is 25.5. So one way, of course, is go and find ACDE, right? But ACDE, I think, will have more points to find. So instead, I go on to find ABC. Yeah, I go on to find ABC or AEC. What did I find? Wait, let me see. Area of triangle. Oh, yes. So that means I highlight the diagram wrongly. Okay. Oh, no, I didn't highlight the diagram wrongly. I went on to find the area of ABC, and then I used 38.5 to minus away the area of ABC to get the area of ACDE. Okay, the area of ACDE, which is the one highlighted in blue. Right, so I need to show that the area that's highlighted in blue is 25.5. So what I've done is I find the area of ABC first. Okay, which come out to be 13 units square. And then I take 38.5 minus away 13 to get the area of ACDE. This one is ACDE. All right. And that is 25.5 units square. Okay. All right. Let's look at the second last question. This second last question. Okay. I'm sorry. Let's start all over again. Let's look at the second last question. This second last question is slightly harder than the previous one because there are more parts involved and also involve more some concepts that we have learned in coordinate geometry. Okay, so basically there are two lines here, line L1 and line L2. So L1 is this guy is your L1. And then the blue one is your L2. Okay, right. And L1 and L2 are perpendicular to each other. Okay, perpendicular to each other, the intersect of the point B. Okay, so what do we need to do? Find the gradients of L1. All right, so that's quite easy. Finding gradients of L1. So we just label the point as x1, y1, point A as x1, y1, point B as x2, y2. All right, so part A, gradient of L1. You can actually use the symbol lowercase m to represent gradient. So that would be, the formula would be y2 minus y1 over x2 minus x1. So that will give you 14 minus away 8 over 4 minus 2. All right, so that will give you my God, 3. Yeah. Okay, so that's correct, 3. Okay, so the gradient of L1 is 3. All right, let's look at part B now. So part B, you are given the find the coordinates of D, given that B is the midpoint of AD. Okay, so B is the midpoint of AD. Right, so let's label. All right, so we do not know the coordinates of D, so I'm just going to let the x coordinate of D be A, the y coordinates of D be B. Okay, then let's label again. So I'm going to label this point again as x1, y1, and then point D as x2, y2. All right, so B is the midpoint. So do you remember the formula to find midpoint? Yes. So the formula to find midpoint would be midpoint of AD would be you take x1 plus x2 divide by 2, then y1 plus y2 divide by 2. Okay, that will be equals to 2 plus A divided by 2, 8 plus B divided by 2. Right, and we are told that this midpoint, okay, this value here, the midpoint of AD, it's the point B. Okay, we are told that B is the midpoint of AD. So in other words, this value here, it's equal to 4, 14. Right. So what we are saying is that this one is equals to 4. This one is equals to 14. Okay, so let's try to find the values of A. So we will have 2 plus A over 2 equals to 4. So therefore A will be 8 minus 2, give you 6. Okay, so 8 plus B over 2 equals to 14. So B will be 14 times 2, 28, minus 8 gives you 20. So therefore your point D will be 6, 20. All right, so that's how you find your part B. So we have found the values there already, so we can just plug in the value. So your point D, it's 6, 20. All right, so that is part B. All right, so part C is to find the coordinates of point C. All right, so point C is the point that lies on the x-axis. All right, so what is so special about points that lies on the x-axis? What do you know about the properties of points that lies on the x-axis? Yes, correct. The y coordinate will be 0. So I'm going to let point C be x, 0. Right. So before we can, there are a few ways of doing it. One way is to find the equations BC. Find equations BC. Let's let y equals to 0 to find the x coordinate. Another way is to use the gradient. Okay, why is it we can use gradient? Because the line AD is perpendicular to BC, right? And if you were to recall, Let's do a recap. If you have two lines that are perpendicular to each other, right? If the gradient of this line is m1, the gradient of the other line is m2, then m1 would just be -1 divided by m2, or m2 would just be -1 divided by m1, depending on which one is given and which one you need to find, right? Okay, so the gradient of L1 is 3. So therefore, the gradient of L2, which is the perpendicular line, will be -1 divided by 3. Gives you -1/3, right? Okay, so now I can use the gradient formula. So how do I use the gradient formula? Okay, let's erase this so that we don't, otherwise it's quite confusing. We're going to label this as x1 or y or x2 because there is high up. So we're going to label this as x2, y2, and this one as x1, y1. Okay, so the gradient of L2, would be y2 minus y1 over x2 minus x1. That gives you 14 minus 0 over 4 minus x. Right, so this value, 14 over 4 minus x, will be equals to -1/3. So 14 over 4 minus x is equals to -1/3. All right, we can just multiply by, just do cross multiply, okay, which is just do a shortcut. Okay, cross multiply and do a shortcut. Right, so you would end up getting a 4 minus x equals to -3 times 14. So negative x is -3 times 14. How much is that? All right, so that will be -42, then minus 4. Okay, I'm going to continue here. So sorry, put the x straight and then continue here. So therefore, negative x is equals to -46. X will be 46. So hence your point C will be 46, 0. Okay, so that's how you find your point C. Right. Okay, so the last part D. So part D, it's to find the area of ACD. All right. Okay, there are two ways of doing it. One way is you can just use half base times height, because you see that your BC is perpendicular to AD, right? So you can use half times base times height. So you will have to use the distance formula to find the length AD, use the distance formula to find the length BC, and half times base times height. But since we just learned the shoelace method and we know all the 3 points, we know points A, points D, and point C, I'm just going to use the shoelace method, okay? Right, so area. All right, remember the half there. A lot of students forgot the half. Okay, a lot of students also forgot to take it in the anti-clockwise direction. So let's arrange the coordinates. Again, I'm going to start with point A. All right, so that is 2, 8. Then go on to point C. That is 46, 0. And then point D, 6, 20. And go back to point A, 2, 8. All right, then use your calculator. All right, use your calculator. Go this direction first. That means 2 times 0 plus 46 times 20 plus 6 times 8. Right, so that gives you 936. Then minus away. Okay, go the other direction. Right, that gives you 408. Right, so then you use your calculator to work out the value, which is the 0.5 times bracket 936 minus 408. And that gives you, wait, I think I made some mistake somewhere. I should be getting 280. Let me check again. Oh, yeah. is 2 times 0 plus 46 times 20 plus 6 times 8. Oh, 968. This guy is 968. All right, let me try again. So it's 0.5 times bracket 968 minus 408 close bracket. Ah, yes, happiness. I get 280 units square. All right. So that's how you use the shoelace method. So this question is rather comprehensive. Right, we apply the gradient formula, we apply the midpoint formula, we apply the gradient for perpendicular lines, and we apply the shoelace method. Right, let's look at the last question. The last question is rather important. Yes, it's important because usually questions, usually exam questions you will be asked to find the coordinates of the fourth vertex. And such a questions, right, if you do not understand that there's certain quadrilateral where the diagonals will intersect at the same midpoint, right, then you can't actually solve. You can, but you will be using that distance formula, solve simultaneously, all sorts of nonsense, right? But if you were to know that certain quadrilaterals actually having the diagonals intersect at the same midpoint, you can just use the formula for finding midpoint to solve this kind of questions, finding the fourth vertex, this kind of questions. So what are the quadrilaterals where the diagonals cuts at the same midpoint? Okay, one of them is your rectangle. Okay, rectangle, the diagonals will cuts at the same midpoint. The second one, it's a square. Third one, it's a parallelogram. And the fourth one, it's a rhombus. All right, so in these questions, you're given a rhombus, right? So let's try to sketch this rhombus. Right, so you have point A, negative 2, 3, negative 2, 3, so negative 2, 3. And then point B, yeah, B is the one you need to find, right? So C is 6, 6. Okay, I think it needs to be further away. Because if this is 2 units, 4, 6, further away. D is 1, 7. 1, 7. Okay, I think somewhere here. All right, so it must go in order, right? So it go A to B first, and then C and D. So your B basically will be somewhere. Let me draw A to D first. Okay, so your B will be probably somewhere here, which I'm going to let the X coordinate be A and the Y coordinate be B. All right, so there's a rhombus. So rhombus means have all the four sides equal. Okay, so the diagonals will cut at the same midpoint. Right, so what they need to do is to find the midpoint of AC. So the midpoint of AC will be x1 plus x2 divided by 2. That will be negative 2 plus 6 divided by 2. 3 plus 6 divided by 2. So that gives me 4 divided by 2, that's 2, right? 3 plus 6, that's 9, right? 9 divided by 2. Just leave it as 9 over 2. All right, then I find the midpoint of dB, which is 1 plus A divided by 2, 7 plus B divided by 2. All right, so this midpoint, basically what we are saying is that this value is the same as this. All right, and this is the same as this. Okay, so that's going fine. So 1 plus, okay. So A will be 3. 2 times 2 is 4 minus 1, 3. Then 7 plus B divided by 2 is 9 over 2. So B will be 2. So therefore, the fourth vertex is 3, 2. All right. Okay, so my point is not exactly accurate. So this is 3, 2. Okay, first part done. Okay, part 2 is to find the area of the rhombus. So I'm going to practice using the shoelace method. So half in the anti-clockwise direction. So I'm going to start with point A as usual. So negative 2, 3. Go on to point B, that is 3, 2. Back to 6, point C, 6, 6, A, B, C, D. 1, 7. Back to negative 2, 3. All right. Okay, so this direction first. You can just use your calculator. And then the other direction. Right, so this will be 23. It's 14.